In this video, we're going to introduce the concept of behavior trees by creating NPCs that will patrol between these tree flags. This is an introductory video if you don't know what behavior trees are and if you have no clue how to implement NPC behaviors. This is a good starting point for you, and we're going to discover how to use Behavior Designer Pro. Okay, let's do it. Let's set up our project and our scene. In this scene, I'm using the RTS camera from my other tutorial. You will find a link to it in the description. Aside from that, I used Pro Builder to make this plane, this white plane that you can see here. Let's go to Window, Package Manager. We need to go to the Unity registry, then look for Pro Builder, and this is it, and you can install it here. By the way, I'm using Unity 6, so if I go to In Project, then you can see that the AI navigation package is already installed. Otherwise, you'll need to install it as well. And for this project, I'm using Toony Tiny RTS Set, which are really good looking assets from Polygon Blacksmith. You can find a link to buy them in the description. And we're going to be using Behavior Designer Pro, which is the successor of Behavior Designer. This is a behavior tree system with a really good visual editor. And for this improvement, the team behind it added dots-powered behavior trees. So even if you're not using dots in your project, the behavior tree itself is powered by dots, and the navigation inside of the tree is done by dots. So you'll get a ton of optimization whether you're using dots or not. As I explained in my Q&A video, NPC behaviors require very fast iteration. And what I mean by that is that you're going to create a basic behavior, then you're going to see what your NPC is doing, then you're probably going to want to modify that behavior, then you go back and modify things and then test whether it's working or not, then you spot something that needs improvement, then you go back. So you go back and forth between the process of designing your NPC behaviors and testing it, and this can be very time consuming. Earlier, we made a behavior tree system that required writing code and creating scriptable objects to create behavior trees. And while that system is good and you can very much use it to create commercial games, for practical purposes, you need something visual that will allow you to quickly iterate over your designs. And also, if you work in a team, perhaps you have a programmer and you yourself are a designer. So you could have your programmer make these scripts or these tasks, and you as a designer, you would use them to create your NPC behaviors. So there are a lot of possibilities here, and we're going to explore them. So I have my scene here. We're going to use Unity's navigation package. Let's go over this level. So this is a plane that I created in Pro Builder. So I went here. If you hold the mouse button while clicking on this icon, you can create a plane. Perhaps you can enable grid snapping, and then you just create your plane. So that's what I did here. So we have some buildings here. We also have walls and a gate. So for each of these models, what I did is I added a box collider, as you can see here. And also I added a NavMesh obstacle. And for the NavMesh obstacle, I activated the carve property. Okay, now that we have our level, so I organized it in this level object. That way I can have all my meshes in here and keep the hierarchy well organized. Now we need a NavMesh surface. So let's click on this plus button. Let's go to AI, NavMesh surface. Here we have agent type set to humanoid or use geometry. Let's set it to physics colliders, and we're going to click on advanced and enable build height mesh. And then we're going to click on bake. So to bring up the NavMesh options, we can click on this icon here, this icon that looks kind of like a compass, and this will enable this little window here. So we can toggle the surfaces, and then we can click on show NavMesh. That way we can see the NavMesh in our scene. So I can see that these buildings have properly carved the NavMesh, and the blue area is where our agents are able to walk. I can see that for this building, it didn't carve it. So let's go into this object. So here I have a NavMesh obstacle, but I don't have the carve option. So let's enable it. And here it's important that you don't have a NavMesh underneath your colliders, because when you're trying to implement some behaviors like wandering around, you don't want your NPC to pick a destination that's inside of a collider. That would cause a lot of problems. So it's better to have a NavMesh obstacle with the carve option. Okay, now I can hide my NavMesh and click on this icon to hide this overlay menu. Okay, let's add a character. So I have this peasant character from the Toony Tiny RTS pack. It has an animator. So in here, I disabled apply root motion. I also added a NavMesh agent, and I didn't change anything here. So we have a speed of 3.5 and an angular speed speed of 120. So you can modify those if you want. And then I added a script to control this character called pawn, and we're going to see it shortly. So let's talk about the animator. I created a new animator here, Tiny Peasant, and this is it. We have one blend tree, which is called locomotion, and we have one parameter speed, which is a float. So if I go into locomotion, I get this. So let's drag and drop our character in here so we can have a preview with only our character. So this is the normal state of the character when speed is at 0. Here we're playing this animation that comes with the package, shield 1 idle, and then if the speed reaches 1, then the character will be playing shield run. This is a very simple animator that will be enough for our purposes right now. Let's open this pawn script. I'm putting all the code inside of this tiny village namespace, and I'm also importing UnityEngine.ai. This is the pawn class. It will require a type of animator. That way, when you add the script to a new object, it will automatically add an animator with it. So we need a reference to a Unity animator and to a NavMesh agent. Then in a region called Unity methods, I'm going to create two methods. So first, an onValidate method. That way, these references are updated in the editor. So if animator is null, we're going to look for it. And if agent is null, we're also going to look for it. Then in the update method, we're going to set the speed of the animator to agent.velocity.magnitude. This is all we need to animate our little peasant. Some of my viewers have contacted me about like the relationship between behavior trees and the NavMesh agent, or like pathfinding in general. And some have asked whether the behavior tree is used to organize the pathfinding of the character. And my answer is no. Behavior trees and pathfinding are two separate problems, or I should say two separate solutions to different problems. The NavMesh agent here is trying to ask the question, if the agent wants to go from this point to that point, what is the path that they'll need to take? So what is the closest path that they'll need to take? And what is the path that will not collide with obstacles? A behavior tree is simply your own code that gives the NPC instructions on what to do. The only difference is that behavior trees are organized a little bit differently than scripts. Okay, so this is a script. This is actually the script from my RTS camera tutorial. In your script, you'll find a class here. It's a class called player. So in this class, you find methods. These are the different methods that I have. I have update movement, update orbit, update zoom, a whole bunch of methods, and each method has code in it that does various things. And here in my late update method, I'm using the methods that I've defined down here. So here I'm using them, update orbit, update movement. So you can think of a behavior tree as the exact same thing as a script. You have these nodes that are called like nodes or tasks depending on the system, but you have these nodes and they have code inside of them. So they're equivalent to methods in your script, and there are specific rules that dictate how these nodes are organized. We're talking about a behavior tree, and when we say tree, we mean like one root. In every behavior tree, you will find one root node at the top. For example, here the root node is a repeater, and then that root node can have child nodes of its own, and each child node can have child nodes, etc. And this makes your tree. So each node can have children, and depending on the node type, this number of children can change. So we have mainly 4 types of nodes. We have composites, decorators, actions, and conditions. So here the repeater is a decorator. Decorators can have exactly one child. So for example, here our repeater has a selector. Then you have the composite tasks, mainly the sequence, the selector, the parallel, and a few other nodes. Then you have the actions and the conditions. So these don't accept any child. These are what's called the leaf nodes, like the leaves on a tree. And usually in your game, these are the nodes that are going to contain your gameplay code. I'm not going to talk about like every node there is inside of Behavior Designer Pro, but we're going to discover some, and we're going to go at it little by little. And we're also going to create our own nodes, mainly our own actions and conditions that will express our own gameplay, and we're going to use them inside of Behavior Designer. Okay, now we want our character to patrol between 3 points. Let's go to the Toony Tiny People package. Here we have these banners. They're good looking banners, but their shader is meant for the Unity standard renderer. So let's import them here in our scene. Then I'm going to go into the mesh and then look for the material. So I'm going to click on this material. That way I have it here. I can see that all of these materials are pink. Since I'm using URP, or the Universal Rendering Pipeline, I'm going to select all of these materials, then go to Edit, Rendering, Materials, Convert selected built-in materials to URP, then Proceed, and this fixes the problem. So here we still have some pink thumbnails, but you can select them all, then right-click and hit Re-import. So in my experience in this project, this will not work unless you restart the project. So you'll have to close the Unity editor, then open it again, because I did it for the buildings and the characters here, and you can see that this fixed the thumbnails. All right. Anyway, this preview window is working. So let's pick a good looking banner like this one. Okay, so let's have 3 of them. I'm going to have one here, and one here. And now we're going to make our character patrol between these banners. So I'm going to click on my character, and here I can add a behavior tree using add component, but I can also go to tools, Opsave behavior designer, then editor, and here I can right click, then add behavior tree. So this has created this component in my object. So we have a behavior tree script with a bunch of parameters. We have a graph name. Here, if I close this editor, we can open it again using this open button here. We have an index. In case you have multiple behavior trees on the same object, you can differentiate between them using index. Then we have subtree. This is basically the external behavior tree that you can have. So we can have a behavior tree in the form of a scriptable object. If you've been following my series since the beginning, this is what we've been doing in our custom system. And here, so you can have either behavior tree inside of this component on your object, or you can have it as a scriptable object that you can share between different NPC prefabs. Here you have the option to start this behavior tree when the object is enabled or when the script is enabled, which is set to on by default. You can choose to pause this behavior tree when the script is disabled. Then you have the update mode and the evaluation type. You can look for those in the documentation. Okay, so let's click on our character and let's open its behavior tree. Now we need to instruct the peasant to do something. So we needed to go to this banner, then wait a little bit and do it for every banner and repeat it over and over again. In order to do this, the first thing we need to add is a repeater. So I'm going to either hit space and you get the list of tasks here, or you can right click and create node and you have the same menu here. So here we have actions, conditionals, composites, and decorators. Our repeater is a decorator. So let's go to decorators and here I can find the repeater here. When I add my repeater without any child, I get this error message. And if I click here, it says that the repeater task does not have any children. So we need a child. And since we're going to have a sequence of events, so when I say the NPC needs to go here, then wait, then go here, then wait, etc., I'm describing a sequence of events or actions. So we need a sequence. Let's right click, create node, then go to composites this time and add a sequence. And I'm going to link it. So I'm going to click here and drag the mouse to link to the repeater. Now our repeater has a child, which is the sequence here. So you can navigate around Behavior Designer Pro using the middle mouse button, or you can use Alt and click like this. Okay. Now we need to instruct our character to go to a flag. First, we need a reference to each banner. Let's go to the shared variables. And here we can add some variables to this graph. There's also the possibility to add variables to the game object itself. If you have a lot of behavior trees working on your object, then you can add variables to the game object to share between all these behavior trees. You can also add shared variables to the scene or to the project itself. So let's add variables to our graph. I'm going to call the first variable banner1 and then click on add. And here it gives me the choice, choose the type of the variable and whether it's a singular value, an array, or a list. So if I choose singular, then go to game object. Here it has created this variable for me. So let's do it again, banner2 and hit add and choose a game object. Then banner3, hit add and choose a game object. So here we could add a list, but I'm going to keep it simple by using a game object. So here, if I close this, you'll notice that in the inspector of my behavior tree, I have these variables over here and I can specify their values. So I'm going to right click on this behavior tree and hit properties. So I can have this window with our inspector and I'm going to assign each variable here. So let's assign the game object of each banner. Like this and like this. Okay, now we have these values available to the behavior tree. Let's open it. Our sequence needs children. So here, the error message that I get is that the sequence task does not have any children. And this is an error that you need to fix. Okay, so our sequence will execute its children one after the other until they all succeed. Okay, so our sequence will need some actions. So let's add some actions. We're going to add a log action, which will print some text to the console. So let's say go into banner 1, and then we can Control C, Control V to duplicate this action and have another log here. Go into banner 2, then we can add some wait actions between them. So let's hit space, action, then wait, but I can also type it here. So if I type wait, then I can find it here. So this is the wait action. It is set to 1 by default, but I can also randomize the duration and choose a range between min and max, but let's keep it at 1. So I'm going to link these actions to my sequence like this, and I'm also going to link this one. Then let's add a wait action at the end of the sequence. I can select this one and hit Control D to duplicate the action and then have it in the end of the sequence like this. Okay, so now if I start the game, if I go to the console, I can see here, go into banner 1, then pause, then go into banner 2, then pause, and you can see the execution of your behavior tree in this window. If an action succeeds, it will have this green check mark here, and the currently executing action, or like any node in general that's executing right now, will be shown in green. So this is a very nice way to see what your character is doing and how they're thinking. Okay, let's stop the game. Here it's important to understand the return value of these tasks. In behavior trees, each task only returns 3 values. It can either return success or failure, or the running status. If it returns success, it means that it has succeeded, and same for failure. And if it's still working, it returns the running status. And that's why behavior trees are so simple to understand, and also behavior tree systems are so simple to create and also simple to expand on. So each of these actions, let's take for example the wait action. So the wait action will return the running status for the whole second here, and it will return it every frame. And then when the second has been elapsed, then it will return the success status. Same for the log action. The log action will simply print this text to the console and then return success. So these are very simple actions to understand, and this returned value will guide the behavior of the composite task. So for example, for the sequence, and here we have some nice descriptions here. The sequence task is similar to an AND operation. It will return failure as soon as one of its child tasks returns failure. If a child task returns success, then it will sequentially run the next task. If all child tasks return success, then it will return success. What it means basically is that the sequence will try to run the first child. If the first child succeeds, then it will move on to the next, then to the next, then to the next. If at any point a child fails, then the whole sequence will fail. The whole sequence will return a failure status, and this will help the parent task decide what to do. For example, here for the repeater has no problem with its child task returning success or failure. It will simply restart again. So the repeater task will repeat executing its child task until the child task has been run a specific number of times. It has the option of continuing to execute the child task even if the child task returns a failure. So here for the repeater, we can either have it repeat forever, or we can have it repeat a set number of times. So it's your choice. Sometimes you want something to repeat like 3 times or 5 times. So you can think of these nodes as building blocks or like Lego pieces. Every node can have different code inside of it, but all of them share this common property of only returning these 3 values: success, failure, or running. It's exactly like Lego blocks. So each block can have different materials, can have different shapes, different properties, but they all have like the same interface that allows them to connect together. So this is basically what a behavior tree is. It's just another way to organize your code. Okay, now let's create our own action that will allow our character to move to a certain point. So I'm going to go to my folder. It's called Tiny Village, and scripts, then tasks, and I'm going to create a go-to object action. Here we need a few namespaces. So these namespaces, opsive.behaviordesigner, runtime tasks, then tasks.actions, then opsive.graphdesigner.runtime.variables, and then Unity Engine and UnityEngine.ai. We don't have to memorize these namespaces. What I do is whenever I want to create a new task, I just copy this code to the new script. So here I have all my code in the Tiny Village namespace. So I'm going to create a go-to object. It will be of type action. Then I'll need a shared variable of type game object. So whenever you want to to reference the shared variables that you define on your graph, you have to declare your variables as shared variables of game object, not simply a game object. That's of course if you want to get the value of a shared variable on your graph, but otherwise, so for example here for the arrive distance, I have a simple float because I simply need to change its value on the task itself, not on the graph. And here we have a reference to our NavMesh agent. So if you're familiar with the first behavior designer, you used to define all the variables as public, and that was the only way to have them on the inspector of the task. But now you can have serialized field as well, as in all Unity scripts. Okay, so let's override the onAwake method. So this method is used like the awake method in mono behaviors. It's used to initialize the task. So the first time that your behavior tree has awakened, this method will be called on each task in the behavior tree. Yeah, I don't even need this base onAwake. It's completely optional. So we're getting the agent, and to access the game object that the behavior tree is on, we simply use game object. So this game object refers to my peasant object. So here my behavior tree is here. So game object is indeed this peasant object. Okay, so game object that get component in parent NavMesh agent. And why do I use get component in parent rather than just get component? It's because sometimes I want the behavior tree to be a child object of my character object, just for organization purposes. If you use get component in parent, the script will look for this component in the object itself, and that's what we want right now. And it will also start looking for it in the upper hierarchy. So it's a multi-purpose method that I prefer using, just in case later on I change my mind and put this behavior tree in the hierarchy of the object rather than the root object itself. Okay, so let's add an onStart method. In the onStart method, we'll set agent.isStop to false. That way we allow the NavMesh agent to move. Then we set its destination. So the onStart method is called right before your task is executed. So when the behavior tree arrives at your task, the onStart method is called. So if you do some heavy initialization, it's better to do it in the onAwake method. That way it's done once and never done again. And for the onStart method, use it to initialize the variables that you're going to need, like just for the execution. So we have a useful has arrived method that will simply check the distance between this destination and the position of the character. So in order to get the value inside this shared variable, you have to use destination.value. This is the actual game object, and then you do .transform.position. And for the position of the character, I'm using agent.transform.position. And if this distance is lower than arrived distance, it means that we have indeed arrived. Then let's override the onUpdate method. So in here, what we're going to do is constantly recheck that the destination is indeed set. So if agent.destination is different from destination.value.transform.position, then we're going to set the agent's destination again. If the path status of the agent is path invalid, we're going to return failure. And if we have arrived, we're going to return success. So if none of these happen, we're going to return the running status, which means that the character is still going to their destination. And finally, let's implement the onAnd method. So this onAnd is the opposite of onStart. When the behavior tree reaches your task, it will call onStart and will start calling this onUpdate every frame. Then when the behavior tree is ready to move on from your task, it will first call the onAnd method. So in the onAnd method, we'll say if agent is on the NavMesh, then we're going to set isStop to true. And here for Behavior Designer Pro, the namespace of your task is very important. In the first Behavior Designer, we had the option to organize these tasks into categories, but right now, let's go to the behavior tree. When I want to add a new node, if I go to actions, so here I have the name of the action, but I also have the namespace. So for example, if you have a lot of actions that share the same name, you will have not only the name of the action, but you also have the namespace to which that action belongs. And this is important if you want a specific action. So for example, here, most of the actions are in the opsive.behaviordesigner.runtime.tasks namespace, but mine is here. So this is go to object and we're going to use it. So let's click on it and this is my action. So here we also have the option of adding a lot of actions into this stacked action node. So when you add your action, the node itself is not exactly the action itself. You can have here a sequence of a lot of actions. And this is very good if you want like a lot of actions, but without cluttering your behavior tree, because we need to keep this as neat and clean as possible. If you want to implement a big behavior tree, then these options can help you reduce the clutter. This is very important. Okay, so I have my go to object action. So here in the destination, I can either directly set a game object, or what I can do is click here, then I can set an object from the shared variables in the graph. So we have this drop down menu here, and I can choose between banner 1, banner 2, banner 3, and also dynamic. Dynamic variables allow you to create temporary variables that are very limited. These variables are great if you want to share data between a limited number of tasks and do not need to access the variable outside of those tasks. Dynamic variables can be created by clicking the circle to the right of the variables field and then selecting dynamic. After the dynamic variable has been created, you can then type the name of the variable. The dynamic variable will have the same value for any field that reference the same dynamic variable. The name is case sensitive and should not be the same as a variable within the tree. Type of the dynamic variable is determined at runtime, and this type should be consistent across all dynamic variables with the same name. Okay, so this is a different way to have variables shared between tasks. You can simply set it to dynamic and specify the name, and as long as the names are consistent across your tasks, then you have this variable that's shared between them. Okay, so banner 1, so let's do it here. And I'm going to delete this log action by hitting delete on my keyboard. Okay, so let's duplicate this action and let's put it here. So I'm going to put it here and also delete this one. Okay, let's connect it to the sequence. And then I'm going to select both of these actions, then Control D. That way I duplicate them a third time. We can place this here for more organizations. Okay, let's put them here. Then what I'm going to do is connect them. And for this third action, I'm going to choose banner 3. Okay, so that's it for our behavior tree. We can either close it or we can zoom out and keep it open to see what our character is doing. There's also a useful feature. So for example, here, if I click on different objects, I will lose my behavior tree, but I can lock it to one object. So I click on my character here, and if I hit this lock button, then this behavior tree is locked to my character. So if I select something else, for example, the behavior tree editor will keep showing me the behavior tree of my character. Okay, so let's run the game. So the character is going to the first banner. Apparently this green A is the first banner. It will wait for a second, then go to the second banner, then wait for a second, then go to the third banner. So it will wait for a second, then it will repeat over and over again. I like to have some fun like this, so I can click on my peasant, then Control D a bunch of times, like a lot of times, and then watch them all go together. So each of these NPCs are using this behavior tree. So each one has their own behavior tree. So you will notice that here, some of them haven't yet reached the banner destination. So they will wait until they're at the banner, then wait for 1 second, then go. And over time, you'll see that they're going one after the other. We can watch them do their thing for hours like this. But anyway, this is like a simple explanation of what a behavior tree is. We can definitely do these things in a script. So for example, if you have a coroutine in your script, you can set the destination of your NavMesh agent, then yield, return, wait for seconds for 1 second, then do it over and over again, perhaps in a while loop. But the advantage of behavior trees is how quickly you can create behaviors. So I can click on a character and quickly create these actions and click on a different character, then organize these actions in another way, thus creating a completely different behavior tree. And here for my character, I can go over this tree, modify it, then quickly see the changes. So this fast iteration component is what will allow you to make NPC behaviors like very quickly and, to be honest, in a really fun way. And it's important to make your work as fun as possible. Okay, let's open the documentation of Behavior Designer. Let's go to Tools, Behavior Designer, then we can go to the welcome screen. So here you can import some samples. In the samples, there is a seek action, which works very similarly to my go-to action here. And you also have a lot more examples to explore what Behavior Designer can do. Let's go to welcome and then let's go to documentation. Here in the documentation, you have this task migration article. This explains the difference in writing tasks between Behavior Designer 1 and the new Behavior Designer. Here in the first Behavior Designer designer, you have to write tasks like this, and there were some conflicts. So for example, for the tooltip, if you want to add tooltips to the fields of your task, then you had to differentiate between tooltip in Behavior Designer and tooltip class in Unity Engine, and you had to use something like using tooltip equals Behavior Designer, etc. But now the new Behavior Designer uses tooltips from the Unity Engine, so the code is much more compact. So here you have things such as like the task icon. If you want to have custom icons for your tasks, you can have a description, and here they talk about other things. So the namespaces, these namespaces here, and they removed the shared variables. So for example, you no longer have shared string, so you need to define all your shared variables, shared variable with the type between brackets, and here they changed on reset to simply reset. So you can use the reset method to reset the properties back to their original values. Okay, then we have the concepts. So here, if you really don't understand what behavior trees are, and if you're not convinced with my own explanation, then you have a lot of great videos that explain exactly what behavior trees, and you also have this article that goes over this stuff. They also have documentations about the variables and their scope, about conditional aborts, and all of these elements. We're going to see all of these concepts in a few examples. So I highly recommend that you read all of this documentation, or most of it, and try to apply it in order to understand how the system is working. There are a lot more concepts, but I feel that it's too much to have all of this dumped on you at the same time. So over the course of many videos, we will start introducing these concepts little by little. I believe this is enough for an introductory video. I hope you learned something new. I'm very excited for this new chapter in the series. With Behavior Designer Pro, we're really going to boost our work and focus more on some interesting NPC behaviors. So have a good one and see you later.